We're at the final stretch of the conference, right? There's a good part and a hard part of it. The good part is I can reference the other folks that presented before me. The hard part is that I have to follow them, right? And I mean, we saw a flying drone controlled with bananas, am I right? Now I have to talk about TypeScript. Yeah. Yeah. I'm joking because I'm always excited to talk about TypeScript, functional programming, and board games, but I'm going to stick to TypeScript for today. All right? And why? Well, it seems like these days on every JavaScript conference, there's at least one person trying to sneak in some TypeScript talk. That's me today, with a good reason, right? Yesterday, we saw during the type annotations talk that there are a need for types, right? And I'm here trying to show you that TypeScript is doing a good job at that. One other thing that we saw yesterday is that we read a lot of code, right? We saw that Uncle Bob said that there's a ratio of reading to write code of 10 to 1, right? That's a very good difference in time that we spend doing one thing versus the other. One good example is that when we're trying to debug or find a bug in our code, and we spend hours and hours reading throughout code just to have one line to fix the code. Anyone? Right? That's a good show of that, right? And many times, that's the kind of experience we have reading that code. It's not a very pleasant experience. We spend a lot of time reading the code, trying to understand. And one other thing that was said yesterday by Moran is that sometimes we don't even understand the code that we wrote 1 year ago. Well, I don't agree with that, because sometimes I look at my code that I wrote about a month ago and I don't understand it. So, yeah. Anyway, I bet we all wanted to have an experience like this one, a pleasant experience reading code. So I'm here to tell you that with TypeScript and a little bit of functional programming, we can achieve some of that pleasant reading code. Now, when I'm talking about TypeScript, and if you look at this screenshot of this old version of the TypeScript website, you're going to see something like this. TypeScript is a typed superset of JavaScript. And that's OK. That helped TypeScript be adopted a lot by JavaScript developers, right? But these days, if you look at the website, you're going to see something more like this, where it says TypeScript is a strong type programming language. And if you want to leverage the most of what TypeScript has to offer, we have to see TypeScript as a strongly typed programming language, not just as a superset of JavaScript. And I'm going to try to show a little bit the difference of what those two mean. Having said all that, I'm not going to be talking about TypeScript 101. This is not an introduction. So I want to raise your hand if you never worked with TypeScript. And by worked, I mean pushed code to production with TypeScript. Let me see if I can see. Not a lot of hands, OK? That's great. But for those of you, right, that don't have a lot of experience with TypeScript, I don't want you to pay attention to how you're going to write that code. I want you to pay attention on what you can achieve with what I'm trying to propose here with this mindset. My name is Thiago Temple. I am a staff developer at Shopify. I flew all the way from Canada to be here. Thanks for the tip, Tejas. I have a daughter named Emma. She's turning 7 today, and she's back home, so happy birthday, Emma. In the past, I have produced a course on functional programming with JavaScript, a course on how to get more from the TypeScript compiler. But today, this talk here is the culmination of my learnings of using other strongly typed functional programming languages, such as F#, not to be confused with C#, although they both use the .NET framework, and Elm, which is a language that its sole purpose is to develop front-end applications. And both of them are fully typed functional programming languages. All right, we're going to talk a little bit about function signatures. We're going to talk a little bit about the AnyType in TypeScript, strings and how we can better use them, what invalid object states are, and immutability. Ready? All right. What is this function doing? And when I'm talking about that, I'm talking about function signatures, right? And the importance of those. A function, be that in functional programming or JavaScript, is a piece of code that takes an input, processes that, and returns an output. That's pretty much it. That's all we're talking about in terms of that. If you look at this piece of code here, and this is TypeScript, taking two numbers and returning another number. And we can infer that because the name of this function is add, and we're taking two numbers, right? Now, if you look at this other function here, what you're seeing is a different story. You know what it's taking. It's taking two arguments, order and order options. But what is returning? Can you tell it just by glancing at this function? I can't. Granted, our tools today, you don't need to read this one. This is VS Code, a print screen of VS Code. I mouse over that function, and I have some help from VS Code. And VS Code is telling me that this function is either returning a string, or an instance of process order, or an instance of order action. Okay, now there's a feature in TypeScript which is it infers the return type of functions, and that's what it's doing here. And what that means is it's going to look at the body of the function, and every time there's a return value, it's going to infer to be one of those possible values there. Now, I may be explicitly wanting to return those, or that may be an accident. Did I really want to return a string? I'm not sure, but if I wanted to, I could create a type to communicate that. And for those who don't know, this is called a union type. A union type means that I have a type order result here. That's the name of the type. And at any given point, I either have an instance of process order, order action, or a string. And now I am being explicit. And just with a single glance, I can know that this function is taking those two arguments and returning an order result, right? Now, if I look at this type here, I can make it even better because string looks a little bit odd there. What I can do is create what it's called a type alias. And now I'm telling, okay, that string means that I'm returning an order processing error. And now that's clear, part of my type. I know that whenever I have an error, it's going to be a string, of course, but it's named there. And people know what to expect when they just see that type. Speaking of error handling, let's look at that function signature again. Can you tell me if this function may throw an error? I don't know. Just by looking at it, I don't know, right? What I do know is that I can avoid throwing exceptions. Wait a minute, I'm going to avoid throwing exceptions? How am I going to have error handling? Well, let's get back to functional programming. In functional programming, we talk a lot about pure functions. And a pure function, staying at a high level, means that I take an input, I process some data, and I have an output. I always follow that pattern, right? What that means is, which is also a very common jargon in functional programming, I have no side effects. And an exception is a side effect because it's breaking that flow of taking an input and returning an output. Now, that still doesn't solve how I'm going to handle an error. Well, we can solve that with a type, a generic type, and again, another union type. In this type here result, I'm either returning a success of a generic type T result or an error of a generic type T error. And if I implement that type, a success is just a simple type with a kind and the value of the success, or a failure is another type with another kind and an error of a different type. Okay? Don't mind too much about the kind there, but the only important thing is that they are unique identifiers to each of those types, so I can know them, and I'm going to talk a little bit more of what that means later. But one consequence of that now is that I have a type order result, that is returning a result, right? And when it's returning a result and it's successful, I know that I'm going to either get a processed order or another action. But if it fails, I know that I'm going to get another processing error, and that is a string, right? And all of that just with a single glance at the function signature. All right. The kind there that you saw, because it was present in both the success and the failure, means the TypeScript knows that this member exists in both types. And now I can inspect that regardless of being a success or a failure, and then determine, okay, if it is a failed result, I have access to the error and I can handle it. But if it's not, then I have access to the value, and it's either one of the two values that I am expecting. All that communicated and ensured by TypeScript. Okay, that's it so far. One thing that I want to mention that we saw earlier, by doing that, we're being predictable. We saw on Matthew's talk earlier, we are adding predictability to our code, right? I forgot to return to this point here. When I'm doing this, I know every time that I am returning another result and may fail. Now, I don't know about you, right? But I don't inspect every and single one of the functions that I call to know if those functions are going to throw an exception, right? So in throwing an exception, I'm removing the predictability of my code. But adding a type that tells me that I may have a failure, it's adding to the predictability and, of course, the reliability of my code, because I'm going to reduce the number of runtime errors that I'm going to get later because I forgot to see if there's an exception being thrown. Now, talking about null. And null is very interesting because null can represent that a value was not found. Null can represent that an error has occurred. Null can represent that an unpredicted case has happened, or that something is not required, or that a condition is falsy, and even more. Right? So that means that null is very versatile, right? Wrong. Null is hiding what I'm trying to tell in my code. Null is a problem. It's such a big problem that in functional programming we heard a lot that the inventor of the null value back in the 50s called it the $1 billion mistake. And if you DuckDuckGo it later, you're going to find what that means. Null is a problem. It's not a solution. So don't use null, ever. Now, if I'm not using null, how can I represent that I don't have a value? Well, let me tell you one thing here. If you look at this function signature and you have find user by ID and you get a null as a result, right? What does it mean to you? Does it mean that I couldn't find a user? Or does it mean that an error has happened? Null doesn't tell me anything about that, right? But an option type, just like we saw the result type, will tell you. Sometimes you're going to see this pattern called maybe instead of option. But an option is telling me that I either have some value with the kind and the value that is carrying, or no value at all with another kind here that is just identifying what that type is. I don't have a value for this. Now, when I'm using this type here to indicate that I'm returning an option of a user, I'm telling the consumers of this function here that if I don't have a value, you're going to get a none as a response. But I'm telling everybody this may happen. And you know that just with a single glance. And once again, because we have that kind that is shared between the two, I can inspect and then use my user when I need it. All right. Before any, water. And any is very interesting, right? Any is the thing that can morph into anything, right? And we use a lot any when we just get into TypeScript. But here's a quote for you. Don't use any as a catch-all for types you're unsure of. Also, don't be lazy. And yes, I'm quoting myself here. When I was using those two languages and I used them as a full-time development, like I shipped code to production and all of that. It was not just a pet project. They don't have the concept of any. That just doesn't exist. Everything is typed, and everything has its own proper type, right? So it's possible to do that. We reach out to any very quickly in TypeScript land. We don't need to do that. But there are some valid use cases of any, right? One of those is when you know nothing about the given value that you're typing as any, and you don't care about that value, right? Those cases, any is valid. Type guard functions. If you don't know about type guard functions, is a small function that takes some arbitrary value, sometimes typed as any, and it makes some checks to make sure that that given value is of a given type, right? You want to make sure of that. And sometimes you need to make it take it any value. And some advanced generic constraints, which I'm not going to get too much into because they are advanced. Matt Pocock was in the house here. He's the guy to talk to about advanced TypeScript. Try to find him later. But if you're not in one of those conditions, I'm going to say to you that you should always default to use unknown. And unknown is a special type in TypeScript that in some cases behavior similarly to any with a different, a couple of different things. One, it's conveying a different message. When you have something typed as any, you're telling everybody, okay, I can accept anything. When you type something as unknown, what you're telling your users is that I don't know what the type is. Eventually I might, but right now I don't. And in terms of the compiler, there's another difference, right? When you start making assumptions of that unknown type, like my args here, I'm assuming that there may be some key in there. I get a compiler error. And then I am required to type that. It's a generic type with a constraint that my object may have or should have some key of type string. And then that's good. So unknown is used for that. You might say, okay, I may have other edge cases that you're not talking about here. Maybe. I would argue that for most cases you can type. But if you cannot type with something other than any, consider two things here. One, if you type something like this here, a user, with a rows of any, and that's a type, or could be an interface, right, that you are exporting and it's being used across. What you're telling everybody across your code base is that whenever you see a user, rows can be anything. So that is a communication spread around your entire code base. As if you do something like this, you are compartmentalizing where the any is. It's just inside of that function. So if you can minimize the usage of any, try to do so, because then you're keeping that in just a small portion of your code. All right, let's go and talk about strings. And with JavaScript, we love to use strings for many different things, right? For instance, let's look at this function here. And this function is trying to find movies by a given genre, right? And it's typed as string. And this is a good example of TypeScript being a superset of JavaScript. Of course, it's typed, right? But if I call this function here, and I get an empty array back as a result, do I know if I didn't find movies for that genre, or did I pass the wrong string? I can tell just by that, right? How can I solve this? I can create a union type. Whenever I have a finite set of values, I can create a union type. And now, if I get an empty string back, that means that I don't have movies for comedy, right? But I cannot pass the wrong string to that function. So if I limit that, I'm limiting my choices, and I'm limiting the possible errors that I may have. Here's another example here. I have an order with any status using another union type. And that status could be either new, paid, shipped, or completed, right? Those are clear there. Those are all the possible statuses that I may have for an order. So people looking at this know what an order can be. Now, here's another benefit of doing that. I have a switch case handling that order status, right? And because I don't have a default return here on my switch case, and I am explicitly returning a type, TypeScript is going to check for me that if I have a value being returned at all possible cases on that branch here, on that switch statement, right? Which means that if in the future I add a new status, let's say pending, this is going to yield an error because I'm not handling all possible cases, right? TypeScript knows that, and it's going to ensure that. Another benefit of that is what I'm communicating here. By having one specific case here for each one of my statuses and not having a default, what I'm telling the people looking at this code is that every single case needs to be handled. There is no a couple of cases that are handled in a way and then a default case that handles all other cases. So that's communication. I'm telling the users of the code, okay, every single case needs to be handled. And if that's not the case, then you can group those cases together. But by not using the default, I'm telling that to folks. All right. Let's talk about make invalid states impossible to represent. And I cannot tell you if this comes from functional programming, but I learned that while learning functional programming languages. And for me, this is the coolest part. So if there's one thing you want to take from the whole presentation, try to make this. It's probably the hardest one as well. So, but let's try a little bit. I have a type here, a type payment. And it has an amount of type number, a member credit card info, and the question mark there means that this is optional. So I might have credit card info. I might have a PayPal info, which is also optional, or this payment here may be made using cash, right? Now, this here is a good representation of TypeScript, again, being a superset of JavaScript. Why? In JavaScript, it's very common that we hold informations in objects and we add members and properties as we need, as we go, right? There's no static type, so that's what we do. So this is representing that. The problem with this type here is that this may happen. Can I tell you how was this paid for? I cannot, right? But this is valid TypeScript. This compiles and this passes. It's 42 amount, right? It was not paid with cash, but I don't have the actual information that I need to tell me how this payment was made. So how can I fix that? One, don't use optional arguments and make this payment info a required member of the payment type. And now I have payment info there, right? And by doing that, now I can create a union type, payment info, that can tell me that this is going to be either paid by credit card, PayPal, or cash. But now this is required and part of the type and compiled, or check at compile time. And my type, by now you understand this, I have a kind for each one of those. If I have a credit card, I may have extra fields, such a number of the credit card, expiration date, and so on and so forth. PayPal info, same idea. And cash is just pure simply a type cash, right? I don't need to know any extra information. That means now that when I have an instance of a payment type, I do need to inform the payment info. It is required. And because it's required, I have to also inform all members of the given kind that I chose to use or was used by the user when created that payment, right? I have a credit card info and a number. So again, I am communicating to everybody that payment always need the extra payment info. One other example. I have an order with an order ID, a billing address, both required, and an optional shipping address, right? Question mark, optional. Why may I not have a shipping address here? Again, I may look at an instance of an order and not tell you, like, I don't have the shipping address. What's the reason for that? I don't know. But if my shipping is required, my shipping with the shipping type, and once again, I have a union type to define that. I can tell you that my shipping may either be same as billing, so I don't need an extra, that duplicated information. Or I'm selling something that is just a digital content, so I don't need to ship it. Or if it is a shipping address, then I may have the address for that. Let's look at those types once again, right? Union types with their unique kinds, and just for the shipping address, I have the address. Again, about communicating what the business logic of my application is trying to do. And once more, everything is explicit and declared, right? I can inspect that kind member and look at each one of those. By the way, the strings here would be auto-completed in your editor, right? And when the moment arrives to use the address, well, it is accessible. And one piece of information that you might want to look into later is that the kind there is the member that was used for the union type. And this is what it's called a discriminated union. So if you want some jargon for you, a discriminated union where I am using a single field across different types, kind, to make a discrimination to know which of them I am accessing right now. So you can then DuckDuckGo it later, discriminated union. So that's it. All right. What happened with my data? Anyone wants to take a crack of what immutability is? Shout out? No? So, immutability. If you have in JavaScript, TypeScript either as well, an object, that object can be changed at any given time, right? You create a new instance of an object, you can access its members and change it. In many programming languages, functional programming languages specifically, that doesn't happen, right? You have an instance of a type, you cannot ever change that type. You have to create a new one. In JavaScript, we're going to soon have, probably, records and tuples that are going to be data structures that are immutable by default. We don't have those right now. But we have some things that we can do with JavaScript, with TypeScript, to make sure that we're communicating that using our code is safe, using our types is safe. For instance, in this function here, I'm taking an array and I'm saying, okay, this array here is read-only. So if you pass down your array to me, I'm not going to change our array in place. So if I call push, pop, or reverse on an array, we're changing that array in place. Sort is another one that is very common that we do. And it's changing the array in place. But if I have that read-only keyword there, I'm telling to everybody using this function here, this is safe. Don't worry about it. I'm not going to change your array. That's good for arrays. But for types and objects, that doesn't work. That read-only keyword doesn't do anything. What you can do is use a generic type, right? But the problem with that one is that it's not going to look at the nested in-depth objects, right? So I can make it order.orderID read-only, but order.customer.customerID is not. So that can be changed. How can we solve that? We can create our own immutable type with TypeScript. And this here is a very intense and dense type of TypeScript code, some TypeScript code. Don't worry about it. You don't need to understand what's going on. But what it's making is it's allowing me to create object types that are immutable in depth with all its nested members. So I can create something like this. I can create a type order that is now always immutable, and it's going to be immutable in depth with all its nested members. So, I can even do that when I'm receiving my arguments, right? So I'm, again, communicating to folks that I either have an order type, in this case here, I either have an order type that throughout its whole existence in my code base, it is immutable, or I can tell folks that inside of this function here, order is always immutable. And then, when I'm trying to make any kind of change to that order, I cannot. TypeScript is not going to allow me to do so. All right, we're almost there. Some final thoughts and a quick recap. First off, compiled code doesn't get stale. So if you can communicate what you're trying to achieve with types, that's a good thing. Comments, well, they don't always work, right? They may get stale. So that's the problem with comments. Use your comments with the why you're doing what you're trying to do, not with what you're trying to do. Think about the next person when you're writing your code, or yourself, right? And if that piece of code looks like some kind of magic, try to make it explicit. Try to tell people what it's trying to do. create types for it, communicate what you're trying to do. Be honest about your function signatures. If it is returning something, tell so. If it is returning an error, tell them so. If it may not return a value, tell your users that you may not return a value. And any is not a escape hatch for you to do anything at all with your types, right? If you don't know what you're trying to do, use unknown. Just don't patch it with any. That's not what it's for. Limit the scope of your strings. If you have a limited set of strings, that means you have a limited set of cases you need to handle. You don't need to handle all possible cases with strings. And especially, if you know that your business logic has some states that you need to define, try to create types that represent that. Having that being checked at compile time is going to be easier for you later. Again, I work at Shopify. We're hiring. We use TypeScript. You can work remotely if you want to. And that's it. Thank you.
Awesome. Thank you.